All right, this says section 3.7, but actually in the new book it has been changed to 1.7. So, but we've always done it in this order, and they still want us to keep us in the order from start state. So we're going to do polynomial inequalities today, and we'll save rational inequalities for tomorrow. All right, as you take a look, we want to solve the quadratic inequalities without graphing. So take a look at this. You have x squared plus 3x minus 10 is greater than 0. Well, just like with a lot of things, we want to find out when it equals 0. And in this case, to find out when it equals 0, we want to go ahead and factor it. So that's going to factor into x plus 5 times x minus 2. Oops, we just want greater than 0. Now for this case here, so it equals 0 at x equals negative 5 and at x equals positive 2. So it is just greater than and not greater than or equal to. Go ahead down on this number line. You put a open circle at negative 5 and an open circle at 2. All right, this is going to be called the test point method. We want to know what points will make this greater than 0. Well, we know where it equals 0. So in between those points, to the left and in between and to the right, it has to be either greater than 0 or it has to be less than 0. So we're going to pick test points, and we are going to test them. And so it's going to be x equals, let's pick negative 7. Let's pick 0. We always want to use 0 if we can. And let's pick 5. Now I'm really only concerned whether it is positive or negative. I do not care what the actual value. You can plug it into the original formula and see what the value is, but I'm just going to test to see whether it's positive or negative. I'm going to use the factored form. So I'm going to use x plus 5 and times x minus 2. And I'm going to plug in negative 7. So I'm going to get negative 7 plus 5, and I got negative 7 minus 2. Well, negative 7 plus 5 is a negative number. Negative 7 minus 2 is a negative number, and a negative times a negative is always positive. So I'm only going to be concerned whether it's positive or negative. So I'm going to plug in 0. I'm going to do the same thing. I got 0 plus 5. I got 0 minus 2. And 0 plus 5 is a positive. 0 minus 2 is a negative. So in the end, it will be negative. And so I'm going to plug in 5. 5 plus 5 and 5 minus 2. 5 plus 5 is 10, which is positive. 5 minus 2 is positive, so in the end that is positive. Well, I'm looking for all the points that make this greater than 0. So those are going to be wherever it is positive. So it is going to now start at where it equals 0. It equals 0 at 2 and negative 5. Don't start at your test points. So all the values that make it 0, so my answer will be x exists in the interval from negative infinity to negative 5 union 2 to infinity for that one. So find out where it equals 0, and then test to the left and in the middle and to the right. Okay, so that's how we're going to start with the quadratics. All right, now if I got x squared is greater than or less than or equal to 2x plus 2. In order to do this, you want it to be set to 0. So move your 2x and move your 2 over. So it's going to be x squared minus 2x minus 2 is less than or equal to 0. All right, now you can go to factor that, but it will not factor. That doesn't mean it can't do it. So we need to use the quadratic root formula. and plug everything in. So I got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so when I substitute in, I'm going to get positive 2 plus or minus negative 2 quantity squared, which is 4, minus 4, a is 1, c is negative 2, all over 2 times 1. And that is going to give me 2 plus or minus. All right, this right there is going to be the square root of 12, and that will simplify to 2 radical 3 over 2. And so when I'm done, I get 1 plus or minus square root of 3. All right, well, that is a real number. And so 1 plus square root of 3 and 1 minus square root of 3 is where we want to go. So square root of 3 is about 1.7. So 1 plus square root of 3 would be about 2.7, right around there, if I remember right. And then 1 minus square root of 3, which is about 1 minus 1.7 is going to be like negative 0.7, so right around there. And it's going to be a solid dot there because it is less than or equal to. All right, now pick your test points. So my test points, I'm going to pick negative 3. I'm going to pick 0. And I'm going to pick 5. So those are all my test points. Well, I don't have a factored form to plug it into, so I got to plug it into the original one. So if I plug in negative 3 squared is 9, minus 2 times negative 3, which would be plus 6, minus 2, it looks like I get 13. Plug in 0. Well, if you plug in 0 into the equation, you're going to get negative 2. And plug in 5. What does that give me? 25 minus 10 minus 2, and I get positive 13. All right, what am I looking for? Less than or equal to 0. Less than or equal to 0 will be in between those 2 points. So the answer will be where x exists in the interval. It will include those points, and it is 1 minus square root of 3, comma 1 plus square root of 3. So that is where though all the x values between there, when you plug that in, will give you a value less than or equal to 0. All right, third one here. Again, same thing. X squared plus 4x. Add 6 is less than or equal to 0. Doesn't factor. Quadratic root formula. Negative 4 plus or minus the square root. 4 squared is 16 minus 4 times 1 times 6 all over 2a, which is just 2. So I get negative 4 plus or minus. All right, what do I end up with? I end up with the square root of negative 8 over 2. All right, what happens when I get the square root of a negative number? That means I'm going to get an I, which is a complex number, not a real root. So it doesn't actually hit the x-axis. Okay, so it doesn't equal 0 in the real number system. So the only way that can happen is if this is a parabola, and since it's a positive x squared, it has to open up. So that means this is a parabola that opens up and does not hit the x-axis. All right, take a look at the problem. It says I want all the x values that when I plug in will make that less than or equal to 0. Well, if you look at this graph, okay, this opens up, it never hits the x-axis. Can I ever plug in a number that will be less than 0, that will be down in this area here? No. So that means in this case, our answer is no solution. Okay, so you got to watch that anytime you get those I's. Now that basically leads us to this theorem. It's called the one-sign theorem. Basically, if a polynomial equation has no real solution, which means you have a complex like square root of -8, square root of -4, then the polynomial is either always positive or always negative. Well, always positive would be a parabola that opens up above the x-axis. Parabola that's always negative would be one that opens down below the x-axis. All right, so those were all quadratics. Okay. We can take a look at higher degree polynomial inequalities. Now this first one here says x plus 3, x minus 2, x minus 8 is greater than or equal to 0. Do not multiply those back together. Okay, we actually want to know where it equals 0. Well, it's already in a nice form because it will equal 0 at x equals -3, at x equals 2, and at x equals 8. So that is where it will be equal to 0. So since it says greater than or equal to, I'm going to put a solid dot at -3, at 2, and at 8. Now we're going to go back to test points. I need to find test points between and beyond where it equals 0. So let's use -5 sounds good. Let's use 0. Always like to use 0. Let's use 4 and 10. Now I am going to use the factored form, and I'm going to substitute into the factored form and examine that. So the factored form is x plus 3, x minus 2, and x minus 8. If I plug in -5, -5 plus 3 is a negative number. -5 minus 2 is -7, which is negative, and -5 minus 8 is a negative. And when you multiply 3 negatives together, you end up with a negative number, which would be less than 0. Since we want greater than or 0, this piece, everything in here would be not in our answer. All right, plug in 0 into x plus 3, x minus 2, x minus 8. 0 plus 3, positive number. 0 minus 2, negative number. 0 minus 8, negative number. So in the end, I get a positive number. So that means that's going to be bigger than 0. So that means this piece here will be part of my answer. All right, plug in 4 into x plus 3, x minus 2, x minus 8. 4 plus 3 is positive. 4 minus 2 is positive, but 4 minus 8 is negative. I end up with a negative, so it doesn't work. And now here, running out of room, 10 plus 3 is positive. 10 minus 2 is 8, which is positive, and 10 minus 8 is positive. And so that's going to be positive. So we also want positive here, so that means that would be part of our answer. And now the final solution set would be x exists from -3 to 2 union 8 to infinity. All right, I'm about out of time. We're not going to worry about this problem right here. This will be the work I need you to do for homework.